All right, guys, this is problem 2008, number 1, and you do have a calculator for this. Part A, you are finding the area of the region R. So finding the area, you're just going to integrate top minus bottom, and you're using your x-intercepts as your limits. So if you look at this integral, the area, your limits go from 0 to 2, top equation minus bottom equation, integrate that straight on your calculator, you get 4. Part B, the horizontal line y equals -2 splits the region into 2 parts. Write but do not evaluate an integral expression for the area of the part below the horizontal line. Okay, for this I think the picture is very helpful. Here's a sketch of the region R. I sketched the horizontal line y equals -2, and I'm trying to find the area of the region below that. So it's still going to be top minus bottom. The top is now -2, and the bottom is my x cubed minus 4x equation. Here's the thing you need to find. You need to find the points of intersection between the line y equals -2 and your bottom curve. So in y2 on your calculator, you're going to put -2, find the points of intersection. The x coordinates become your limits. Now again, you're just writing the integral. Do not evaluate it, okay? Don't take time to evaluate it. Part C. The region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Find the volume of the solid. All right, we're perpendicular to the x-axis. That means we're going to do top minus bottom. And we're building with squares, so we need to integrate the area of a square, which is side squared. So for this one, my limits are 0 to 2, and volume is the integral of side squared. I'm integrating the area of a square. To find the side, top minus bottom, squared, put that on my calculator. You have to evaluate this and get your final answer. Make sure you're going to 3 decimal places. Final part, the region R models the surface of a small pond. At all points in R at a distance x from the y-axis, the depth of the water is given by h of x. Find the volume of water in the pond. Now, this is very similar to part C. The only difference is that bounded region is the top. Instead of building up on that region with rectangles, we're building down. So when they tell you the depth of the water is h of x, that's a fancy way of saying it's the height. So what you really have here are rectangles. The base is going to be top minus bottom. The height is going to be h of x. So again, it's just re-explaining this problem, rethinking it to realize that you still have rectangles. So when you look at part D, volume is base times height. That height is actually the depth of the pond. So the base is top minus bottom, same limits, 0 to 2. The height is h of x, that was given to us. And again, you have to evaluate that on your calculator and make sure you round to 3 decimal places. That's it.